So are you talking about a specific problem that is configured somewhere?
Yeah, it's already there. It's there in one of those PPAs, I guess. Yes, sir. Right. Trying to pull out something. One second.
Okay.
So which we have not. One of those things.
Okay. Meanwhile, is there anyone else who has any question?
Hello, good evening, sir.
Yeah.
Sir, I have posted a question in the chat box. I didn't understand that question. It's a week 5 question, practice assignment question number 10.
Okay. Week 5. Week 5. Practice assignment. Practice assignment 5. Practice assignment
10th
5.
question.
Okay. So 10th question is this, right?
Yes, sir.
Okay. So this is the function big factor. It is
Sir,
doing
excuse
something.
me, sir. Your voice is little bit low, sir.
Yeah. Right. Yeah. So this is the question. M is a prime number. What will this return? Right. So which return statement will get executed? So if M is a prime number, say big factor of 5. I call something like this. So Ravina, right?
Yes, sir.
Okay. Which will return statement in line 7 get executed, or will return statement in line 5 get executed? So can you tell me what difficulty you are facing?
Sir, I don't understand what means which return will be executed because I don't understand this whole looping and all. I just know that this n%f equals to 0 is counting the factors of this n. Only this
Okay.
much I understood.
Okay, we'll start from that. So what you are saying, if n percentage f double equal to 0, then what is f? F is what?
A
Whatever you just.
factor.
Okay, f is a factor of n. Okay, so that much you know, right?
Yes, sir.
Okay, so if f is a factor of n, then what will happen? Will line 5 get executed or not?
It will be executed, sir.
Okay, so if you are able to find a factor of n, then which return statement will get executed? 5 or 7?
Sir, it will be 5.
Okay, so this line number 5, so based on your understanding, then I can say that line 5 will be executed if f is a factor of n, right? Is that clear?
Yes, sir.
Okay, now when will, so for a prime number, how many factors does it have?
The number should be itself only.
Okay, number itself or 1, right? 1 or, so
Yes,
for
sir.
5, the factors of 5 are 1 and 5, right?
Yes, sir.
Okay, so now if you see the loop, okay, next question you have to ask is how long does this loop, or from what values of f is this loop actually active? So take the case of 5. I substitute n equal to 5 here. So for what values of f will you keep looping?
Sir, it should be between 2 to 4.
Okay, so correct. So f will be 2, 3, 4. Correct?
Yes, sir.
So if f is 2, 3, 4, then will this line will this evaluate to true, this condition for n equal to 5? For any of 2, 3, 4, will n percentage 5 percentage 2 be 0?
No, sir.
Okay.
3.
For none of these, right? It will not be executed for it. It will not be true for any of these.
Yes, sir. Not. It will
Okay.
not be true.
All right. So now I'll go back to the question. Can you say which return statement is going to get executed?
Then the outer return statement, sir.
Okay. Let's just check that. What does it say? Where is the answer? Yeah. So the return statement outside the loop, right? So this line 7 is what will get executed. So if you have a confusion, then you must take a concrete example like this and then work through the loop. Mostly you will get the answer.
Okay, sir. Thank you, sir.
Yeah.
So now I got the question, sir. I'm able to trace it out.
Yeah.
Can I ask? Okay. So this one is op 1, OPP 1, mock 5.
Question 1 is it?
Mock 5 question 1.
Mock 5. Yeah.
So OPP 1. OPP 1 mock 5. Yes, sir, this one.
Yeah. Okay. So can you show me what code you have so far, written so far?
Yes, sir. I'll just share this screen.
No, you paste the code so that I can.
Oh, okay, okay. I'll do that. So I don't know whether my logic or whatever I thought of was correct or not. There might be some way that I would actually. Pasting the code in the chat. Might be totally different approach. Maybe it's completely wrong, but I just try to just understand. You see that, sir?
Yeah.
I was trying to do this way. I'm not sure if it's right. No, it's completely out the camera.
So this is a string, right? Your interpreter won't recognize this as the plus symbol.
Yes, sir. Yes, sir.
So this won't work, right?
Yes, sir.
So you need to take a different approach. So there are only two operations, right? Addition, subtraction. So you don't need to encode them.
Mhm.
You can directly add when you encounter a plus and subtract when you encounter a minus.
No, no, no. I think the input is going to be like that, right? The whole question is like somebody inputs the string like this, like 1 + 2, something like that. They
Don't know.
Hello?
Yeah.
So as per the question, like what it says is it's a simple word problem. No? So when he is typing out, just have to give the results. So how to go about it? Because they are going to type it as -1 plus something like that. They are going to type it like this.
Yeah. So see, this will not work, right? You can't. I mean, how you can't expect a string to stand in the place of the plus operation, right?
I got it, sir, but how do we approach this thing?
So as I said, whenever you encounter a plus, you don't You just add it. You just add it to the sum. So one way to approach it is I can't modify the existing code. I'll have to.
Yeah, can you show me the code, sir?
So-
This is completely wrong, but what is the background?
So 1 plus 2 plus 3. You always start with I suppose you always start with something, right? The operator.
You can start with even, yeah, yes, sir. No, sir, you could start with a word which is equal to number. Let's say it could start either by, let's say 1, 2, 3, something like that, or it could start as minus or plus. It can start anyway.
Yeah. So only thing is that no two consecutive words will be the same. So if you now you can define this, right? This is so this is a must. We have to do this. So when you essentially go through words, let's see how to do this. So you go through each word and I'm going to assume that by default the operator is plus, right? So if the word happens to be a number,
Mhm.
and if the operator happens to be plus,
Mhm.
then I am just going to say that the sum is the value of the expression is going to be d of word, right? I'm just going to add the word. Else the operator is going to be minus, so I'm going to subtract the word. And if the word is an operator, if word is an operator, then if the word is minus, or rather if it is plus, then let's use some weak 11 concept. So it's plus if word double, not word, the operator will be plus if word is double equal to this, sorry. Okay, you don't, essentially you don't need this IV. Okay, so let's before we go to the else part, let's stop here and take one example. It will be easier. 1 plus 2 plus 3. So I start with plus. I come across 1. So the word is in D and operator is plus. So I add 1 to the expression. Then I come across plus. Okay, so if word is equal to plus, then operator is plus, else the operator is minus. Okay, I don't know whether this will work or not, but we can try our luck and see where we go with this. Okay, there's a syntax error. Where is the syntax error? 0. colon. Should be colon. Okay, we have
For the second, it is starting with minus.
yeah. So it is starting with minus. So let us try this out. -2, -1 + 2 -3. Okay, so it's starting with minus. So we start the loop here, word in words. If word in D, word will not be in D. So if word double equal to plus, no, word is not plus, word is minus. So operator is currently minus, right? So see, this is a spelling mistake. So it was operator. It was operator. Let's see if that fixes it. Okay. Okay, so this is one way of solving this problem.
Can you show the code, sir? I'll just go through that once. Then can you paste it out in the chat?
Yeah. Okay. So yeah, so this is one way of solving the problem. Right. So does anyone have any other questions?
One question here also.
Yeah.
In this code.
Yeah.
One second.
In the else part, when operator is equal to minus, how it know that it have to be subtracted?
So when the operator is minus, I update the operator variable, right? See, the idea behind the solution is always, yeah. So the operator and operand always alternate, right? So -1 + 2 -3. So it's like you never have something like -1 1 2 3 + 5 5, right? So it's always, they always alternate. So before every number, you know for sure that there is some operator. So so the idea is I need to figure out before a number what operator is present. So in this case, before 1, I need to know that there is a minus. So how is that taken care of? That is taken care of by this flag called operator. Right. So when it is, say for example, when it is minus, operator, when you're reading this particular digit in the string, in the sequence of words, the operator's value will be minus.
No, sir. Here in the else of else part, if operator is minus, that I understood.
Okay.
How the code will know that it has to put minus sign before 1?
See, that is because of the way the expression is structured, right? So -1 + 2 -3. So if I want to compute this, evaluate this, how will I do it? In Python, it will just be -1. So it will be 0 -1 + 2 -3, right? So when it is a minus, I just do this minus equal to 3. So when it is a minus, I just add the negative sign this way. Is that clear, or there is still some confusion?
Not clear, sir. In the second last line, operator is equal to minus. All right. And when will the code know that it has to put minus sign before 1?
So it will know it. It will know it
is not in D.
Yeah. So minus is not in D, but I am not asking. So see, you have to look at it as a pair. You have to look at it as pairs of operand comma operator, right? So these two happen together. These two happen together. these two happen together in the sense consecutively, right? So when I am reading this particular symbol in the loop, which part gets executed? Which
Second
line?
last.
Okay, so this particular line gets triggered, right? Line 20.
Yeah.
So operator is minus after you have read this particular word in the sequence. Now when you are reading 3, which line in the code gets triggered?
Okay. Line 15.
Yeah, so line 15 gets triggered, right? So what is line 15? Line 15 is nothing but value minus 3, right? The minus sign gets added there.
Okay, understood, sir. Thank you.
Sir, I have a doubt, sir. I think it's not clear to me.
Sorry?
So what I'm saying is like for the same thing here,
Yeah.
-1 plus 2 minus 3. So first thing is, let's say for this one, since we are looking at word in words, so first word would be minus. So obviously straight away it will go to else, right? I'm sorry, for if word in D, which means that here we don't find minus at all in D, right?
Yeah.
It will go to else. It will go to else, and the operator now is word is not plus, but word is minus.
Yeah.
So it's executing the last line, 20th line, right?
Yeah.
So operator is minus. Now after that, the next word was let's say 1. Yeah, 1. Okay.
Right.
So I go with 1. I go with 1 inside, and then val equal to. So how is it? Minus is we're not accounting for the minus at all, right?
The same
Because-
thing I just told, right? It is 0 minus 1.
Okay, now if it is 1, then first one, for second letter is 1. So second word is 1. Now I am looking here and I'm getting word in D, that is 1 for 1. I'm moving to 1 and I'm getting 1 here. So val will be equal to val plus, which is 0, 0 plus 1. Okay, 1. Fine, okay.
Yeah. So what you need to do is you need to spend some time with the code, right? So
But it is plus 1, right? It will not be minus 1, no? For this one.
minus 1.
Yes, sir. But the code is generating only 1, right? Not minus 1, because the first minus is just we are not adding it into the computation at all, like that.
No, minus 1. 0 minus 1.
Okay.
Yeah. So what you need to do is the best way of understanding a code which you have not written is to take one example and go step by step, right? See, if you write the code, then you are the master of it. When you are reading the code that someone else has written, the point of entry is through examples, right? So you'll have to take up one example and work through the code until you are able to get at the bottom of it. Okay, so just spend some more time with this, and then you will figure out what the logic is.
Sir, sorry to interrupt. I joined a bit late. If I'm not wrong, this is mock question number 5.
Yeah.
Right, sir. So I guess we discussed this question previously as well, and I posted this solution in discourse as well, and there is a complete description of that. So maybe if someone get confused, so he or she may refer that option as well.
Yeah.
It's in discourse,
Yep, it is in discourse.
Discourse has become a
but searching for this one should take some time because
no. I mean,
I thought
yeah,
it's so much of ocean like that.
discourse has become kind of a. Yeah, I don't want to comment with all this
So
bonus.
it's like now it's like a needle in haystack kind of thing. Actually, so can you probably I want to zero in on this fast rather than trying to rummage through all the codes. So how do I get to it faster?
Right. So if you permit, sir, may I explain this code if you allow, and if time
No.
is allowed?
See, I already explained it.
Okay.
As I said, so the point is not me explaining more or you explaining more. The point will be the best way to understand someone else's code is to break open it with the help of some example, right? So take a test case. I think the code is simple enough. Given that we are in week 12, right? There is one for loop. There is just one if else here, and this if else is very trivial, right? So you don't need, it doesn't, I don't think it needs explanation. Only thing is that you need to break this down. So it's very simple. If it is plus, then you add the number. If it is minus, you subtract the number, right? So that is all there is to the code. And if the operator is plus, you make it plus. If the operator is minus, you make it minus. You loop through the words. That's all, right? So
Sir, why we are defining operator is plus on line number 5? It will all check on itself by line number 14 or 17.
no. So sometimes what happens is, if it doesn't start with an operator, for example, +1, you usually don't say +1. You say 1 plus, right? I mean, you start with 1. For positive numbers, the sign is, if the sign is plus, right, it is not mandatory to add that. So that is why you need this operator of plus to begin with, right? So as I said, so just work through this for some more time and you will get it. I just want to take some other questions also, given that the upcoming exam is the theory exam.
I shared one question in chat, Mr. Karthik.
Sir, will any mock be released soon?
See, there are many questions. Please work on them. The mock, don't take mock very. I mean, mock is important in some respect, but have you worked through all these theory questions in the portal? That will be a pretty good exercise, I would say.
Yeah, sir. Sir, I have a problem in week 5, sir. PPA 4. Can you please explain?
Okay, so we can get to that. I just want to know if there are any other theory questions that
Yes,
anyone
sir.
has.
Sir,
That will be given preference.
I have a question from practice assignment 5, last 2 questions.
Okay, so that is.
May I ask one question in this question?
This will come to it at the end. No, I mean, we have been discussing this for like half an hour now. Not that I don't want to discuss it, but we'll finish theory parts before we.
Question number 12 and 13.
Yeah.
Sir, what would be your advice to prepare for the theory part actually? Because code we can write it, we can practice, attempt different questions, but theory we can't actually prepare in that sense.
You just need to. You can just go through all these graded and practice assignments, right? That should be enough. Just go read through the code. Try to find the. So one thing you can do is you can execute that first. Without executing that piece of code, try to understand what it's doing. Then you execute it to verify your answer. So you could do that.
Okay, sir.
Okay, 12 and 13. Can you tell me what the query is?
Sir, I did not understand like how this code is working.
Okay. All the 4.
No, 12 I understood a little bit, but 13 means how 12 is used in 13, that I do not understand.
How 12 is used in 13. Huh? So you are multiplying a list. Okay, this should be actually P. Anyway, so this is. Okay, do you see what the correct options are in 12? Are you able to see that?
First option and last option.
Okay, so first option, because it just adds all elements in P to R, and then it adds all elements in Q to R. So first is correct. What is last? So last is essentially creating a copy of P and then it is appending all elements in Q to R. Okay, so
Yes,
first
sir.
and last are correct. So you that I think is clear to you. This is just concatenating two lists. Now what we are doing is, you understood the question, right, in 13?
Yes, sir. I understood the question.
Okay, so P you have to just replicate it n times. And so what is your query here?
Like how means how the code is executed. This means like this whole thing went over my head.
Okay, so let's take function by function. So in exam you won't have access to this interpreter. So let's try to see concatenate q comma q will do what? So if q is 1 comma 2, what will concatenate of q comma q do? Can you tell me the output?
It will concatenate another list.
Will it duplicate that?
See, if q is 1 comma 2, can you tell me what will be the output of this?
Is 1 comma 2 comma 1 comma 2.
Okay, so this will return 1 2 1 2, right?
Yes.
All right. So so if you start with empty q and you do this n times, what will q be in the end? So essentially what I'm saying is I am starting with empty list. So what will this give you? Concatenate of empty list with empty list?
Empty list.
Okay, so I do this n times. So in the end, what will be the value of q?
Empty list.
Okay, so it's empty list. So there's no point. This is certainly wrong. Okay, do you agree that this is wrong?
Yes, yes.
Okay, then we'll go to second one. Okay, here we are concatenating P with itself. Okay, I'll give you one. I'll give you this function and I'll give you one list. You tell me what. You tell me what will be the output. Let's say n equal to 3.
Okay, then 1 comma 2, 1 comma 2, 1 comma 3.
That is what you want, but is that what this function is doing? So we'll just look at it let's take n equal to 1. If n equal to 1, how many times will this loop run?
1 time.
1 time, right? So what will be what will be q at the end of the loop?
1 comma 2.
1 comma 2, and that's all. You are concatenating this P with itself, right?
Yes, 1 comma 2 and 1 comma 2.
Okay, so this will be the value of q for n equal to 1. Okay. Now for n equal to 2, what do you think will happen?
It will happen 4 times, like 1 comma 2, 1 comma 2.
Okay, but you are not updating q at all, right? You are once again doing only concatenate of p comma p. The second iteration also, it is same 1 comma 2, 1 comma 2, right? It is p. P doesn't get changed here, right? P remains the same.
Yes.
So whether n is 2 or n is 1000, what do you think will be the output of multiply of p comma n?
It will return like 1 comma this only.
This only, right? It will always be 1 comma 2, 1 comma 2. It won't change. So this also is wrong. So these two are wrong. Now what about this? This is the third option. Let's start with n equal to 1. So if n equal to 1, you should tell me what the function will return.
1 comma 2.
So if n equal to 1, it will return 1 comma 2. If n equal to 2, what will it return?
2 times 1 comma 2. Like 1, comma 2.
Okay, 1, comma 2, 1, comma 2. Okay, what about n equal to 3?
So then 3 times.
Okay, so this seems correct. So how do you argue that it is correct? So this
So
is
every time this queue is getting updated.
exactly, yeah. So every time q gets updated, and before q you add one more copy of p in the ith iteration. So if q was so the formal way to put this is, if q has n minus 1 copies of p, then in the nth iteration, right? Nth iteration, q will have n copies of p. Q will be one more copy of p.
Yeah.
Okay, so that is correct. So this, I believe this is correct. We need to check it, but this is correct. Okay, so we know that. Now let's look at the other one. There are two more to look at. This is what. Okay, what is the difference between these two? See, this is another trick. Okay, so this is another trick. What is the difference between these two?
Q is not initialized.
Okay, so this is straight away out. Okay, so this cannot be right. Or can it be right? Can't be right, no? So Q is Q. I will be referencing Q, but then it will throw an error because Q is not defined. So that brings us to the last function.
Okay, it's the same one, only Q is
Yeah.
the front.
What is the difference between this and the other correct option?
Like in this one, P is concatenated with Q.
Yeah, just the order is changed. Okay, so that is the only difference. So yeah, so these two are correct, right? So this is the way you
Thank
get.
you, sir.
Yeah. All right. Any other theory questions? Does anyone have?
Sir, I have question from repeat PPA 15.
Okay, we'll get to that. Anyone else having theory? I'll just exhaust theory before. Okay, if no one has theory, then we can go to programming. Which one?
Sir, week 8 PPA 15, sir. Recursion problem. I've been trying to understand, but like I couldn't write the inductive case.
Oh, subset sum.
Yes, sir. Yes, sir. This problem, yeah. I think it will take some time.
Okay, so you have set number of coins, and you need to see if there is a subset of coins that is whose sum is equal to s. Right, so subset sum, you accept the list of integers and the sum as arguments, and you have to return true if there is a basically is there a subset of numbers in L that sums to s, right?
Yes,
So
sir.
is there any approach that you have used which is not working? Have you tried any approach so far?
Yes, sir. I tried the approach that is given in the discourse, sir. So like I couldn't understand the.
Okay. All right. So see, there are the basic idea is, it's a very long time back, right? So this, we had a very good discussion on this in the last term with some of your seniors in one of the live sessions. So we'll try to get to that. Okay, so let's take the first element of the set of the list. Okay, so if this happens to be a part of the subset, okay, then what can you say about the sum? See, S is the sum you want to achieve, right?
Yes, sir.
So if L of 0 is a part of the subset, then you can break this problem into two parts, right? S minus L of 0 and L of 0, right? So L of 0 is the first element in your bucket, and then you need to fill the remaining sum S minus L of 0 with the coins in the rest of the list. Okay, so
Sir, can you please explain the problem, sir?
So
Actually,
you mean to say the L of 0 is a part of the sum that S?
yeah, okay, so someone is asking me to explain the problem. See, the problem is actually a very good problem. You have certain number of coins with you. So let's say 1, 2, 3, 4, 5. You have 5 coins with you. These are the values of the coins. Now you are given another number called S equal to 6 in this case. And the question is, can you take certain number of coins from this locker or list, and does it sum to 6? So in this case, you can see that if I take coin 1 and coin 5, that will give me 6. So you return true in that case. Here, for example, you have these many coins: 1, 9, 10, 5, 8, 13. That is the value of these coins. 6 coins are there. You want to get the sum of 26, so you need to pick some coins. If you look closely, you can take 1 and 10 and 5. That will be 16.
2 coin of 8 and 1 coin of 10.
2 coin. No, you can't take 2 of 8. You can't do that. You can take only 1
5,
coin.
8, and 13. 5, 8, and 13.
We can take
5 and 13, sir.
Okay, 5, 8, and 13.
5, 8, and 13.
Okay, so that will give you 26. So it's true. In this case, it's harder to prove. No matter what combination you take, you will never get 21 as the sum of the coins. So you have to return false. So that's the basic idea of the question. So subset sum. Can you find a subset of numbers whose sum is equal to S? Okay, so one approach is there are two possibilities for the first element, right? Two possibilities. Either it is a part of the subset, so it is not a part of the subset. So you have to consider these two branches. Okay, so if subset sum this is the remaining part of my list, right? I look at all the coins after removing the first coin. So this is part 1. It is a part of the subset. Then this should be true, right?
Yes, sir. Yeah.
This has to be true. So then I say that, you know what, if this happens to be true, that is, if L of 1 is part of the subset and I am able to find in the smaller locker, right, after removing the first coin, in the smaller locker, with n minus 1 elements, if I'm able to find some subset which sums to s minus L of 0, then you can return true. So if this, the other branch is, if what is the other branch? It is not part of the subset, right? So no matter which subset I take, L of 0 can never be a part of that sum, right? Part of that set of coins which will sum to S. So I drop L of 0 totally and I go searching for this sum S through a smaller subset of numbers, n minus 1 numbers. In this case also I return true if I happen to find it.
So, session is recorded, sir.
I think someone is recording, I don't know why, but yeah.
If we want to see it later.
This will be streamed. I think it is being streamed.
So YouTube, we can see it later, right? Like,
Yeah. Okay, so this is the part of two branches, right? So you branch into these two parts. Now the interesting part will come when you ask, what if there is, so the corner cases, right? The base case of the recursion. So this is a bit tricky, right? This is something we discovered last time.
Sir, can you explain this to the code which like you are checking only the first element, right, sir? Whether it is within that subset or not, right? Or
right. Yeah, so I'm checking whether the first element is within the subset or not. So I'm considering both the possibilities, right? Whether the first element is there or not. It will include in some case, in some sense, every possibility. We'll come to that. So if the list is empty, what can you say? I keep doing this process and I end up with an empty list.
To check whether S is 0.
Okay, and I also need to check if S is 0, right? So in that case, I can return what?
False.
True, right? Because I have achieved S equal to 0. So in fact, I can have this S, I can just take this away and say if S is equal to 0, then return true. If at any point of time you achieve this 0 sum, that means you are already there. Right? Now if L is empty and S is greater than 0, that is you no longer have any elements in your locker, but still you have a non-zero sum, right? Or a positive sum. So in that case, what can you say?
False. Subset, false.
This has to be false, right? So okay, now think about this. Think about this case where S minus L of 0 happens to be negative. Say I have my first coin in my locker is 100, but I want sum equal to 5 only. So this is like 5 minus 100. So this will be minus 95. So is that being captured anywhere?
No.
All right. So this probably should not be greater than 0. It should be not equal to, I think, right? Because anyway, let's first run it. I mean, this will be like a confusing piece of code. It can be tough to get this right in the first attempt. 3 out of 4 passed. So we are missing out on one test case.
Negative case we are missing.
Yeah, I don't know which one we are missing out on, but it seems like that negative one only. So this is coming out to be none. Okay, let's debug this part. So SW equal to 0 will not be a problem. Okay, so it need not be empty, right? So let's add one more here. If S becomes negative, then you just terminate it right away, right? Because there's no way you can continue that particular branch. Okay, so in that case, I can go ahead and add. In fact, I don't even need to add this, right? So I'm making many changes. I'll come back and explain. If this works right, then I will explain. If not, we'll debug once again. Again, missing out on something. Okay, so can someone see what could be going wrong here?
So there can be a case where S is greater than 0 and L is not empty. I think.
There could be a case where S is greater than 0
And L is not empty.
and L is not empty. Huh?
Yeah.
Okay, so see what all can happen. Let's look at what you said. So if S is 0, then there's no problem. So the true case is not going to affect us at all. If S is less than 0, then again there's nothing to solve because we cannot get a negative sum with L.
In the question, sir.
Yeah. Yeah. So just one second. Give me 1 second.
Yeah.
Okay. So this. Yeah. So just 1 second. Just 1 second. I think we are missing one last condition of these two not working out, which is why I think it is not giving us. It was not giving us. Okay. So now we have. So did you understand what was happening?
No, sir.
Okay. So see, this is. Okay. So the basic idea is this, right? This, did you understand? If you have say coins like 1, 2, 3, 4, 5, and you want to find a subset that will give you 6, right? So you want to find out a subset, not find out. You want to see if some subset of coins will sum to 6. In this case, you have 1 and 1 plus 5. So in this case, you have 1 plus 5. Now the question is asking you, is there some subset like this? That is all it is asking you. So the approach that you take is, in your locker, you isolate one, right? You isolate the first coin. So L of 0 is the first coin. Okay, now if you add it into your subset, so if you add first coin to your subset, if you add your first coin to the subset, then what is the what remaining sum should I account for?
S minus L0.
Okay, so this I think should be clear, right? I have added my first coin to the subset. So I need to account for S minus L of 0, right? Now, I no longer have access to the first coin. So I can only search in the list 1 colon, right? This is my smaller locker without the first coin. So I continue the search in the smaller locker. And if this returns true, what does it mean? It means that there is some subset of elements in L of 1 comma 1 colon which sums to S minus L of 0. Correct? So if this is true, then there is some subset of elements in the remaining part of my locker which sums to S minus L of 0. So I return true. Is this part clear?
No, sir. Can you explain once
So
more?
we did check all the subsets of this branch, like all the possible subsets.
Yeah, so this that will happen implicitly, right? So this will make sure that it checks for every possible subset in the remaining part of the locker, and it will tell you if that has some subset which sums to S minus L of 0.
So there is another branch also, right? The other if statement.
That will come to that. Yeah, we'll come to that.
Okay.
So now,
Sir, can you explain this one, sir? So I got it that every time you are taking one coin out of it, and like this search will go on, right?
yeah,
But how it will make it true then? Sir, that part I'm not getting.
yeah. So this for this, you'll have to look at. There is a way of visualizing this. It's in the form of a tree structure. So I can pull up that diagram, but see, at each stage, what are you doing? You are making one binary choice, one binary decision. Is my element there or not? Correct? Yes or no? For every element, you are making the choice. So if there are 5 elements, 5 places, right? So 1, 2, 3, 4, 5. At each place, you are making 2 choices. So you are at every element, you are branching into two parts, right? There is a branch factor of 2 here, 2 here, 2 here, 2 here, 2 here. So you are actually considering all 32 subsets in this process. There are 32 subsets, right, for this set. Do you see that? There are 32 2 power 5 subsets.
Yeah.
How, sir? Can you explain the last comment? Last 2 comments.
Okay, so I am hearing my own voice. Okay, yeah, it stop. So see, there are five elements, right? Okay, wait. I need to pull up one diagram, and then it will become clear. Where is this? Just give me a second. So one of your seniors asked this question. I'm just trying to figure out where that is.
And I've shared the discourse link in the chat box.
Yeah, subset sum. Okay. So Rachita, your senior, she only brought this up. last time. Okay, so can you see the screen now?
Yes.
Yes.
Okay, see what is happening is if you take a list like 1, 2, 3, 4, 5. Okay, so I mean you can split it as two parts, right? Here I'm taking the last part and then the first 4, but it doesn't matter. You separate it into two parts, 1, 2, 3, 4, and 5. So oh no, sorry, this is the list and this is the sum that you want to attain. Okay, so this is your locker, it has 4 coins and you want to find if there is a subset of coins which sums to 5. So what do? You take the first coin out. So 5 minus 1 is 4, right? So you want to see if within the smaller subset of coins 2, 3, 4, is there a subset which sums to 4? Okay, so that is one branch. The other branch is I totally ignore this coin 1. Okay, so I totally ignore this coin 1 and I ask from my remaining coins 2, 3, 4, is there anything which sums to 5? So you have to convince yourself that at this stage there can be only these two possibilities. Either coin 1 is there in the subset or coin 1 is not there in the subset. Okay, so this is what I meant as this branching factor of 2, right? Where is that? Yeah, so at the first stage it branches into 2. Now for each of these branches, notice that there are another 2 branches. So 2, 3, 4, I need to sum to 4. So I take 2, subtract it from 4. So that is one path. The other path is totally ignore the coin 2. Same here, 2, 3, 4, and 5. I subtract 2 from 5. I have the sum as 3. Or I totally ignore the coin 2. Okay, so finally I end up with something here. Okay.
Sir, but by doing this method, how it is ensuring that sum will make it to whatever, like say suppose 5 here. If we are like in two ways, like we are doing one subtracting and another ignoring it. So
Yeah. Yeah. Can you mute? I think there is an echo from your end, right? See what? By this way, you are considering every possible subset, right? You are considering all 32 subsets, 2 power 5 subsets of the. So in including and ignoring, what are you doing? So
Excuse me.
yeah.
Sir, I want to conclude something, sir. Tell me if I am wrong or not. Sir, first if condition we are applying, so we are getting the subset one by one. Like we are getting one element only, and then we are subtracting it to our S. Okay. But in our second branch, we are just neglecting first element because of the fact we are not taking one by one element.
We are ignoring that from our subset. We are saying that is not a part of our subset.
Yeah, because like our first if condition is going to only like check one by one, no, like if it first and second term adds up to our S.
Yeah, both the conditions check one by one only, right? So both are in some sense, one is including, the other one is ignoring. So the first if condition includes, the second one ignores. This is inclusion, and so I don't want to write this as else because it's not really else. So the other one is you are ignoring the Okay, so these are two branches. And if both these branches return false, I mean, if both are false, if you are not able to find the sum, then you have to return false here. This is what we missed earlier. So is this clear? I mean, it won't be clear in the first code. This is a very non-intuitive way of approaching it, but
so how why are we ignoring the first element of the subset or the set?
see, the basic idea is this, right? If you have a list of elements, then I'm essentially encoding a subset like this, right? So this is how I'm encoding a subset. So 0 means it is not in the subset, 1 means it is in the subset. So this will actually represent what subset? 2, 4, 5. Okay, so this is actually a binary representation of subsets. If you think about it, 0 means it's not there, 1 means it is there. So if by this process, this is what I was telling earlier, you can represent all 32 subsets for a given set of elements. That is exactly what you're doing in these two if conditions. Here, including this is the same as saying that coin 0 is in. This is the same as saying that coin 0 is out of the subset.
So will there be 32 subsets or 64 subsets? Like for both the branches, like
there will be 2 power n, right? 2 power 5.
Yeah, 2 power 5 for the one branch and for other branch also.
No, right? So if you look at this image, this left branch is all subsets that include 1. This will give you all subsets that include 1 because I have subtracted 1 from this, right? So this branch will include all subsets that do not have 1.
Yeah.
So there will be in all there will be 32 such subsets. So if you have to go down to this tree representation and understand it a bit more to see that there will be this was in the last live session. This is the number of recursive calls and not the subsets, right? So this is, I mean, you'll have to read this post, right? There is
subset will be 30.
Yeah.
It calls will be.
Yeah, so is this clear now? Is it at least partially clear what is happening?
Not clear.
Okay, then you'll have to think more, right? So you'll have to, it's very tough to, beyond this, you'll have to, sit with the problem and compare the image and actually try to see what is happening. Right, but this is the idea. So just ruminate for a while. Element is in or out. There are only 2 ways.
So how to come up with this kind of inductive case? Like
this is very tough, right? I mean, don't worry about.
So this comes from practice or like how?
No. This even our instructors, we also didn't do it from scratch. I mean, this is a very standard problem. So subset sum. If you look at Wikipedia, right, it is there in all several places. This is there. So it's a very standard problem in computer science. So see this. Whatever we have used is in some sense this inclusion exclusion. Right? This is the naive algorithm. So if you read it, The most naive algorithm would be to go through all subsets, right? There are 2 power n subsets, and you check if each subset sums to that number or not.
This is a problem of depth first search, right? Like I found this on the Discord search. Depth first search.
Yeah. So this is one. If you read this post, which I think this is also mentioned.
As going through that post,
Yeah, I don't know where it is mentioned, but this point is there. I think it is in this or some other post. There is a mention of DFS. But yeah, so don't worry too much about how do you come up with this in the first place. This is one of the toughest problems in the entire course. So okay, so any other questions?
Yeah, yeah, sir. And like week 5 PPA 4, sir. Can you explain?
Sir, week 12.
Okay, we'll finish this. This one.
No, sir. I think week 5 PPA 4 is there, right, sir? Or just a minute, sir. Yeah, PPA 5 is, sir. Week 5 PPA 5 is.
Okay, first maximum, second and third. Okay, can you tell me, have you attempted this code?
Yeah, sir. So I have followed the process, but I am getting wrong output, sir. So I'm just
Okay, can you
not
show
able to
me
see.
your code?
Just a minute, sir. Actually, I posted in Discord, sir. So right now I don't have. I will just copy from Discord and paste it here.
Yeah.
So meanwhile, you can take some other problem. I am just logging to Discord. It will take 2 minutes time.
Okay, anyone else? Any
Sir,
question?
week 12 PPA 13.
Week 12. Okay. Yeah. So what is the doubt here?
Sir, when I tried to code, like I was getting the dictionary for each of the each items, but when I was appending that to list, then there was some error, like it was repeating the same dictionary.
Okay. Do you have the code with you?
Yes, sir.
Okay. That is what will happen, right? You need to create a new dictionary for every transaction. You are only having the same dictionary outside, so this should come inside. And now if you run it, it might work. Okay, so we have to
Sir, T should capital. Not small.
yeah. Yeah, so that and the C being small and the dictionary being outside the
Okay, so we have to create dictionary inside the loop.
yeah, right, because you have one dictionary for each transaction.
Got it, sir.
Yeah, sir, I've just pasted. I've sent you in that chat, sir, that code which I've written.
Yeah. So week 5 PPA. Why is I think while you copied it from this course, the formatting got messed up.
Yeah, sir, I think there. Yeah.
Okay. What is this? Does anyone know the command for okay, for x in L if so first max, second max, third max. If x is greater than the first maximum, then third max becomes second max. That is correct. Second max becomes first max. That is also correct. First max becomes x. That is also correct. If x is between first maximum and second maximum, then third maximum becomes second maximum. Second maximum becomes the x. X is greater than third max, less than second max. Then third max becomes x, right? Not second max.
Yeah, sir. Okay, but
I
I
think
think if okay.
that is all is the mistake, I believe. No, that is not all. Something else also is wrong. So let's see. F max, S max, T max. T becomes S, S becomes F, becomes X. So you don't need to even have equal to, right? They're all distinct. So let's just go with less than. If X lies between S max and F max, then T max is F max seems correct. Okay, I don't see any mistake here apart from that one thing. Okay, I don't know why that equal to made so much problem.
Okay, sir. But sir, suppose we are, can we take one example, sir? If suppose there is one 1099 as a list, and then how it will be executing the code?
For equal elements, is it?
Yeah, yes, sir.
We will try it and see that. First underscore 3 of 10, 9, 9, 8, 7, 7. So it will come like this, right? 10, 9, 9. Okay, so this is like start off with something very easy. So let's say something like this. So then you need this equal to sign kicking in here, right? So
Yes, sir. There I max.
so you don't need, probably you don't need it here, but 10 here, I think it will be 10, 9, 9. So this equal to matters, but when you're having equal elements.
Yeah, sir.
Okay, any other questions? Anyone?
Sir, big 12 PPA file.
Oh, balance.
Mr. Karthik, I have very small question.
Yeah.
That is for this practice, programming practice question number 1, printing 1, 2, 3.
Okay.
So can you please look into that, or I'll just post it again into group, into chat.
Yeah, which question number is it?
Just now I posted into the chat. It is programming test question number 1.
Okay, programming test. Okay.
Yes, this one.
Yeah, so this is, yeah, can you tell me what the issue is?
Means what should be the code? This is hard coding, right?
Yeah, we have to hard code, yeah.
No, we cannot do like it goes up to the, for example, we have taken n in range, for example, 5. It goes till 2, and then it start decreasing. It goes till 3, then it start decreasing. It is going till 4, then again it 1, 2, 3, 4, then 3, 2, 1, like this, like palindrome sort of thing.
You could do it that way also, but since it was like week 1, right? We just asked it like basic printing exercise.
Okay, fine. Then it is okay. This one is, of course, can be done.
Yeah.
I thought we have to code in some way.
Right, yeah.
Sir, can you paste the last code which again just I will go through once.
Sorry?
Can you please post the ping that last code which you wrote, right, sir? So yeah. Yeah.
Okay, so this is week 12 5, yeah?
Yes, sir.
Okay, so this is a tough one, right? This is also okay. So the question is, you have an expression made up of this parenthesis and it is balanced when it follows all these conditions, right? So whenever it is open, it should be closed, and it should be closed with the same type. So easiest way to understand this question is to look at some examples. So I'll just type some. So is this balanced or not?
Not.
It's not balanced, right? Because it's not enough if the number of open brackets is equal to closed brackets. It cannot be closed and then open, right? So this is like closed and open. That is not allowed because of condition number
3.
Yeah. Yeah, maybe it's a mixture of conditions. So so this satisfies one, right? This particular thing satisfies one. The number of opening parenthesis is equal to the closing parenthesis, right? So 1, 2, 3, 1, 2, 3, and same way for the square brackets. So one is satisfied. An opening parenthesis cannot be immediately followed by a closing parenthesis of a different type. That is also satisfied, right?
No,
So,
I think it's not satisfactory because it's a closed.
see, opening should not be immediately followed by closing. So here that is true, right? Opening is not of a different type, right? So that is not happening. It's happening here, right?
Yes.
It's happening here, right? Yeah. So this violates condition 2. Every opening parenthesis should eventually be closed by a closing parenthesis. That is also violated because this is open. There is nothing to close it after it. So there's something to close it before it, but we are not interested in that. Okay, so is this problem clear? What balancing means?
Yes, sir.
Okay, so intuitively, I think you all understand what balancing means. It's just that you need to express it in a certain manner so that it's error free. Okay, so there is one way to go about this. Just to maintain a list, right? What this list is doing will become clear. So this first thing is you just go character by character, right? I'll just take one example here. Okay, so opening, I just want to make sure I understand what an opening parenthesis is and what a closing parenthesis is. Okay, so O represents all my opening fellows and C represents all my closing fellows, and they are matched index by index, right? So first is open, same here is closed. Second index is open, here it's closed. So this is important. We'll see why it is important. So when you come across a character in this word, right, and if it is empty, right, and the character happens to be in one of the closing parentheses, then what can you say about this word?
It's not balanced.
Right. So for some of you, it may be. I mean, I have not told you what R is, so it may be totally confusing. See, R is something that is always balanced, right? So you can think of R as some subset of this word or some substring of this word from left to right that is always balanced, right? Or that is so far not unbalanced. Does anyone get what I'm saying? R is a list of characters in word that are so far in a balanced, okay, I would say that are potentially balanced. Okay, so did anyone get that? What I meant by that?
Hello. Audible? Everybody audible here?
Yeah. So I was just asking if the use of R is clear or
No, sir, please continue. We are trying to understand it because there is saying R is on the empty list, nothing else. So we are not getting what it.
okay. Yeah, that is true. I mean, it's very tough to make sense of this particular approach.
Sir, hello.
Yeah.
Sir, I have coded this program. Could you please see it?
Yeah, sure. We'll come to that. This is one particular approach that I want to demonstrate.
Sir, I am only getting one test passing here. Other two cases not satisfied.
Yeah, we'll come to that. So, see, this is easier if I first demonstrate what I am doing.
Yes, sir, please continue.
Yeah, sir. Okay, sir. Continue. Sir.
Okay, so you have a string like this, right? So, basic idea is I just want to take character by character. So, first I take opening bracket, right? And I add it to, so consider line 3 as a list, okay? List, I don't want to confuse it with the list brackets, right? List the open and close parenthesis of list. So assume that line 3 has an empty list. So this opening bracket is my first element. Then the next element in word is a closing bracket. Sorry, opening square bracket. So I add it. Okay, so potentially it is still balanced. I mean, it is not yet hopeless situation, right? So the next thing is I go for this flower bracket. That also seems fine. Okay, now your list has these 3 elements. The next thing in your word is the closing parenthesis, right? Now, the moment you see this closing parenthesis, moment you encounter a closing parenthesis, you ask, what is the last element in my list? Last element in my list is an opening parenthesis, and it is of the same type as the closing parenthesis. So what I do is, I kind of add this to the list temporarily, but then these two cancel each other out because they are balanced. They are locally balanced. So I remove the 2 of them from my list.
Yes,
I take up the next element. Okay, so that is also locally balanced with my last element in the list. So I remove them. Finally, I take up my last element in the word. That also balances out the element in the list. So finally, I end up with an empty list. I started off with an empty list, and when I pass through all characters in my word, if I can end up with an empty list again, then it means it is balanced. Okay, this is the basic idea. So let me take up one case where it is not balanced. You will understand what this approach is actually. Okay, so start with an empty list in line number 6. Take the first element here, square bracket. Okay, so far the list is potentially balanced. Now there's an opening parenthesis. Go ahead, add it. Now this is the first closing parenthesis that you see in your word. Unfortunately, if you add it, there is no way to balance it. So when something like this happens, you stop and return false. Okay, so your list is now non-empty. You have to stop at this stage because there is no way you can balance this expression. Therefore, the whole expression is unbalanced.
Yes,
okay.
Got it.
Okay, finally, let's do this also. I start with an empty list. Now, remember that when you have an empty list and you hit an opening parenthesis, there is nothing to balance this with. So I return false then and there. Okay, so this is what I was writing here. If your R is empty and if you are trying to push a closing parenthesis into R, then you can straight away go and return false, right? There's no way it's going to be balanced. Okay, now if R is not empty and this character is in the opening parenthesis, right? It's okay. You can append it to so no harm in that. If R is not empty and the character is in a closing parenthesis, then if you recall, you have to compare it with the last element, right? Last element in R. So how do you do that? If R of -1, this is last element in R. So the last element in R, remember, will always be one of these opening parentheses. Okay, so I look at the index of that last element to determine what type of opening parenthesis it is. and this is a closing parenthesis, right? So I also determine what is the index of the closing parenthesis. And if the two are not equal, then I am in trouble.
Yes, sir.
Okay, so if they are equal, then I can do this cancellation, right? So whatever I did here. So let's take this example. I add this, I add this, I add this, and then when something that matches comes along, I remove it. So that's what I'm going to do here. When something matches, I'm just going to pop that element. And pop is nothing but remove the last element from the list R. Okay, so
It's equal to remove last.
yeah, it is the same as just removing the last element.
What pop is the last element?
Yeah, pop will remove the last element.
Remove the last element.
Okay, so now finally you just check if R is empty at the end of the whole process. If it is empty, then it's balanced. If not, it is unbalanced. So we'll just run it just to make sure that I'm not sure if it will work exactly. We might have missed something. And we have missed out on this test case. Let's see why this is not working.
So, sir, why we are abandoning only a non-empty list in line number 13?
Right. Yeah, there's no reason why this should be non-empty. You are right. If it is no, you just append. Yeah, that is the mistake. Okay. Okay, so that is the idea. So this the whole thing is based on what is called a stack data structure, which you will study in the next course, PDSA, by Professor Madhavan. Okay, so this will come up very early on. So stack is like it's like, can think of it like a book stack, right? A stack of books where you pile things on the top, right? And then you remove from the top. You cannot remove a book from the bottom. If you want to remove a book from the bottom, you have to remove all the books that are there on the top. So you can think of R as a stack, right? Stack of open brackets or open parent. Don't know the spelling, but let me stick to brackets. So R is a stack of open brackets. Okay, so you keep adding these open brackets to R. Whenever a matching closing bracket comes, you remove that open bracket from R. So you keep removing this until R is empty. So if finally you end up with an empty list, that means your expression is balanced. If not, it is unbalanced. Okay, so I think that is all. There are no other questions. We can close.
Sir, one thing just need help, sir. For matrices, sir, I am.
Sir, when is the next session?
Next session will be on I don't know when it will be, but next week we'll have at least one revision session for Python, all weeks.
Sir, I have a request, sir. Sir,
Yeah.
I have coded this problem. Could you, sir, see where I am going wrong, sir?
Okay.
Sir, I have post my code in chat box, sir.
Yeah. So okay, this approach is slightly tricky because there are too many subcases, right? Too many special conditions you have to check.
Firstly, I am checking number of opening bracket and closing bracket same.
Okay.
Then I am going to one by one and followed by check whether this is opening or close, that type of things.
Yeah. I'm not saying this approach is wrong, but it can be tricky because see, there are some long-term dependencies, right? So
yes,
you're checking I and I plus 1, but from somewhere before I might have opened something, right? And I might be closing that now, and so it's kind of tricky, right? So that's why the whatever solution I shared, it gets rid of this case by case analysis.
Yeah, sir.
Right, it can be very tricky, so I need to dig into it a little more to see where exactly it is not working.
Because it's checking for only 2 consecutive indexes.
Right, so you might have opened some bracket in like 10 characters back, and you might be closing that now. So right, you are checking as Devendra,
Yeah,
or
sir, I am checking one by one and followed by whether this is close or opening type, this types of clause.
correct, but it can be tough, right? Because see, for example, the first test case itself, if you run it, I believe this might not pass the first
Only
test case.
one test has passed.
Right, so see, first test case it's failing because you open the first bracket in character 0 and you're closing it right at the end, right? So you're not capturing that here anywhere, right? So this is, if you write it this way, it's a bit tricky. See, where you succeeded is in this case where it's open close with a different kind, so you can easily catch these things. But these long range dependencies, right, where it's tough to catch. All right, so we'll meet again. I think next week we'll have a session for revision session for all 12 weeks.
Okay, sir.
Sir, just one thing, sir. I am actually facing issue with the matrices, sir. So in the lecture I can understand, but when the problems come for like, so I'm unable to do it, sir. So any suggestion how I can?
Matrix, huh?
Yes.
Matrix.
Revision sessions will be there, sir, in the next week.
Yeah, revision session will be there. Maybe you can, until then, what you can do for matrices is
What should we do for the revision, sir, for the end-term examination? Whether we should go by writing the codes or we should go through the theories only?
no, only go through this. Best way to revise, I would say, is go through all these assignments. Where is that? There are some fairly complicated pieces of code coming up in, say, here,
And
right?
whether we should go through, yeah.
Yeah, please go through all these things and try to find the answer without executing it. That should be enough.
Assignments. We should go through the assignments, sir.
Yeah.
All the weeks, right?
Yeah, all the weeks. Yeah.
Coding part is not so complicated. Coding things are there because we are weak in coding. So
Yeah, you don't need to code. You just need to read the code.
Understand the understand the code. What
Yeah,
the
that
result
should
will be there like that.
that should do. Yeah.
Thank you. Thank you.
Yeah. So matrices, I see you'll have to sit down and go through the whole thing, right? I don't have a, other than practice and try solving several matrix based things, I don't have a better suggestion.
Okay, sir.
Okay, so just go through wherever. See, one thing you can do is in GRPA, some matrix codes are there, right? Look at the solutions and see how it is done. So all that will also help you.
Okay.
Right.
Yes, sir. Thank you.
Okay, so thanks everyone. Thanks for joining.
Thank you very much, sir. So nice. Thank you, everybody.
Thank you, sir.
Thank you.
Thank you, sir.